This is Peter Mowen demonstrating Lab 6, an introduction to digital signal processing on the Zybo and FreeRTOS. In this video, I will cover the hardware setup used for this lab, including the interconnections between the Zybo, the PMODs, the oscilloscope, and the function generator. And then I will demonstrate a piece of standalone software that does not use FreeRTOS. It was provided by the professor. It just reads in a signal and passes it straight through to the output. After that, I will show a naive approach of doing the same thing with FreeRTOS. And after that, I will show a better approach using FreeRTOS that will have a higher throughput. And finally, I will show a piece of software that reads in the signal, takes the square root of the voltage, and puts that on the output.
So here we have the hardware setup for this lab. We're using an electronics explorer board made by Digilent. We're using its arbitrary waveform generator to generate a sine wave. I've got the sine wave going into oscilloscope channel 4 and also coming over to the A to D converter, which is then connected to port JE, the top part of port JE on the Zybo. And then coming out of the bottom part of port JE, we go to the digital to analog converter, which is then connected to, so it's this brown and black wire is connected into channel 3 of the scope. I'm also looking at the chip select pin on the A to D converter. It's on oscilloscope channel 1. Also looking at the chip select pin from the D to A converter, and it is on channel 2. Now, just to show that I'm running on the hardware, I've opened the SDK and waveforms. I'm generating a 100 Hertz waveform, which is offset by 1.5 volts. The A to D cannot read negative voltages, so I've moved the wave so that it will only be positive voltages. So let me load. I will run the standalone version on the hardware. Run as launch on hardware, and you'll see down here it's starting to load. You saw it flatline there. That was the code being loaded to the Zybo, and now it is just passing it through. Channel 3 is, recall that channel 3 was the output from Zybo, and channel 4 is the output from the AWG. So over here, we've got waveforms running again, generating a 100 Hertz tone offset by 1.5 volts. I will just show that we are indeed running the standalone software. Run as launch on hardware. It'll take a minute to show that it's loading. And there we see our code was loaded to the Zybo, and channel 3 is what's being read in by the Zybo, and channel 4 is the wave that's being generated by our arbitrary waveform generator. So something interesting to look at is how many samples can we send in 1 second, and we can look at that we can figure that out by looking at the chip select signals for the A to D and D to A. Recall that channel 1 is looking at the chip select signal for our analog to digital converter, and channel 2 is looking at the chip select signal for our digital to analog converter. So this falling edge represents where the A to D is acquiring a sample. So it acquires a sample and then waits, and then when the blue goes low, that's it's writing the sample out, and then it's some more overhead, and then the next sample is read in. So all of that takes about 4 microseconds. which implies that we're running at about 250 kilosamples per second. So just to show that this software does work, it does the thing that we expect it to do, we will run as, launch on hardware. It does its thing. You can see that it is just taking the sine wave in and putting it back out. So again, let's figure out the throughput by looking at the chip select signals. And this time, the 1 microsecond division isn't enough to see a full period. So let's go to 2, and we can see that it's taking a little less than 6 microseconds. Actually, it's a little bit more than 5 microseconds. It's about 5.3 microseconds, which implies that our throughput in this case is 189 kilosamples per second. And it's slower because we have the overhead of FreeRTOS on top of just waiting for these signals to go high and low. We'll run it on the hardware. Run as, launch on hardware. It'll take a sec. There we go. And to see what our throughput is, we'll take a look at the chip select signals. And looking at our chip select signals, we can see that the period of the A to D and D to A is much shorter. It's a little bit less than 3 microseconds. I estimated it to be about 2.8 microseconds, which gives us a throughput of about 357 kilosamples per second. And that's about a 43% increase over the standalone, the naive standalone version of the software. And if I calculate the percent increase over the FreeRTOS naive version, so that's 357 minus 189 divided by 189. That gives me about an 89% increase over the naive FreeRTOS version. And that's pretty cool. And that'll take a minute, and it's going. And oh, that's because I'm locked on channel 1. Let's lock in on channel 4. And let's look at the rising edge. So the green line is our input, the magenta line is our output. And if we take a look at the graph of a sine wave shifted up by a sine wave with an amplitude of 1 shifted up by 1.5, that's our red line here. And then if we take the square root of that, that's our blue line. What we get in the wave generator, or what we see on our oscilloscope, is pretty close to that. So I think we did an okay job there. So now if we take a look at our throughput, and let's turn that to falling. If we take a look at our throughput, notice we can't even get a whole period here with the division set to 1 microsecond. So we'll set the divisions to 2 microseconds, and let's just run this once so it stops twitching. And we can see that 1 period is about 7.7 microseconds, which implies that our throughput is about 130 kilosamples per second, which is a lot slower than all of our other runs. But it's actually doing data processing as opposed to just passing samples through.
So in conclusion, we saw how to use the Zybo to do digital signal processing, both with standalone software and using FreeRTOS. We also saw that FreeRTOS could have a negative impact on throughput if used naively, though if used intelligently, we could increase throughput. And we also saw how to use FreeRTOS to do some basic digital signal processing.